All right, people, here's our test review. Find the pH. The pH is the negative log of the molarity. So you just punch in, shoot, let's just do number 2. Let's do it. Let's punch in that number. 0.0000323, and then you just hit log negative. That's a pH of 5.5. pH of 5.5. This problem right here, you would first find the molarity, 0.325 grams in 1.5 liters is equal to how many moles in 1 liter? Well, this number right here can't be used because it's grams. So we're going to say 0.325 grams divided by, for HCl, 36 grams. That's H plus Cl. So let's find out how many moles that is. 0.325 divided by 36. 0.009 molar. So really, and we've done 50 of these in class, kids. Really, should read 0.009 moles per 1.5 is how many moles per liter. Cross multiply. Gives 0.006 molar. And with 0.006 molar, log negative is the pH. pH is 2.22. I don't know if I'll give you one this hard on the regular test. Honors, you'll definitely have one this hard. I don't know about you regular people. All right, you'll see that these words have changed because I think some of the words I gave you originally maybe weren't good to fit this graph. So if you had a hard time with that, I totally understand. But I'll do these words right here. Windex, that's a base. And super strong ammonia cleaner, that's the other base. So that would be the Windex. And that will be the super strong ammonia. Does that make sense? We put a C here, an F here. Water is going to be B, that's at 7. Strong acid, we'll say that's G. Orange juice, that's an acid, we'll say that's A. All of the OH negative producers, that's this letter up here, it means all of them, D. My hydrogen producers, E. Give the pH of the following substances. All right, that one, that little number right there, that's a pH of 6. Now, if a substance has a pOH of 4, then it has a pH of 10 because it has to complement. It has to come up to the number 14. Water is going to have a pH of 7. Let's follow acids or bases. Duh, base, base, acid, acid, acid. The only type of cleaner that's ever going to be an acid is if it cleans metal. Calculate the molarity. 12 grams in 600 milliliters. This is just like the first problem I did in the review. Is equal to how many moles per 1,000. All right, I'm writing 600 and 1,000 because we're talking about milliliters here. We can't use this number. That's grams. So we say 12 divided by 58. It's 0.206 moles, or 0.207 moles. I just leave the number of my calculator, right? That's what we always do in class. So now we got to solve for this moles. So times 1,000 divided by 600 times 1,000 divided by 600. 0.344 molar. All right, this problem is exactly the same thing. We'll skip down here. What is the phase at negative 40 and 1? Negative 40 and 1, going to be right here. This is solid, liquid, gas, so it'll be a gas. What's the phase at negative 20 and 100? Right there in liquid. Moving from gas to liquid, what would that be called? Be called condensation or condensing. If I'm going too fast, people, watch it in. It's a video. Shoot, you can even have YouTube make me talk really slow. I have to talk quickly or I won't ever be able to upload the videos. I'm going to do 25 and 27. How many grams of sulfur dioxide can dissolve at 60 degrees Celsius? All right. Sulfur dioxide, here it is. Boom. 60 degrees Celsius. Very little. I don't know, 2 grams maybe? Some really low number, right? Number 10. If 10 grams of potassium chlorate were dissolved at 30 degrees Celsius, this solution would be 10 grams of potassium chlorate. Let's see, here's potassium chlorate. 10 grams at 30 degrees Celsius is right on the line. Here is the potassium chlorate. Oh, potassium chlorate. We're above that line. Here's the line for potassium chlorate, and we're above it. So that will be super saturated. Remember, our answers to these blanks are saturated, unsaturated, or supersaturated. Here's one I bet you want to see. S1 over P1 is equal to S2 over P2. The solubility of methane at 20 degrees Celsius, 1 atmosphere. Our first pressure is 1 atmosphere, and our first pressure is 0.025 grams per liter. What will be the solubility at 1.4 atmospheres? So we're looking for solubility 2. We will obviously cross multiply. 1.4 times 0.025 divided by 1, duh, same answer, 0.035 grams per liter. 0.035 grams per liter. This is Henry's law. There's videos on this. You did a worksheet. Dilution. The formula for a dilution is M1V1 equals M2V2. A 0.6 molar solution that was at 400 milliliters is diluted by adding 90. So our second volume is 490. It's not 90, it's 490. What's the new molarity? It's going to be weaker. I'm going to cross multiply. 0.6 times 400 divided by 490. 0.489. 0.489, or actually that would have to round up to 0.5 molar. That's good. Hydrobromic, nitric. No O, say hydro. Ick, just nitric. All right. Then we did a titration. Some of this isn't on yours. I think I only got this on here for the honors people, but 33 milliliters is our first volume, right? Here's our first acid. It's the same formula we were using right here, same formula. 33 milliliters, and we don't know the molarity of that acid, is equal to 0.06 molar base at 50 milliliters. So how strong was this? 0.06 times 50 divided by 33. 0.09 molar. All right, everybody, there's our quick test review. There, look at all the videos from the last 2 weeks if you have any questions about any of this stuff.